Hello Techies, welcome to our YouTube channel Local Techies. You're watching Performance Testing Series Video 2 by me, Sneha Bellala. Now let's dive in. In today's video, we are going to explore the topics regarding performance test terminology, Little's Law and where it is used, performance testing tools and tool selection. Then we move on to LoadRunner introduction and we will see how to download and install LoadRunner. Now, when learning and getting familiarized with any skill, we master the terminologies and jargons associated with it. Same applies here too. Let's first see the concept of V-users or the virtual users. Virtual users replaces human users in a scenario. Imagine a scenario where you have to test for 500 users manually. Then, if you do this, in a manual performance test, you have to acquire 500 personnel and 500 systems for them. And for testing a click of a button, you have to say like ready, get, set, go, and now click on sign in. So this is practically not possible, and even the results will not be accurate, and it will be very difficult to collate them. So when you run a performance test, these virtual users emulate the actions of human users by submitting the input to the server. In a performance test, we can have tens, hundreds, or even thousands of virtual users. Virtual users, in short form, we call it as V-users. Then, let's see what is a pacing time and a think time. Think time and pacing time has significant importance in performance testing. While designing the workload in the workload modeling phase of performance test lifecycle, both are used to control the transaction rate during the load test, but both are different. Most of the time, many may get confused between think time and pacing. A simple one-liner would be, think time is nothing but the time between two transactions. Pacing is the time between two iterations. Confusing? Let me explain. Both are used to create a real-world scenario. Think time commands the virtual user to pause the business flow in between for a given period of time. This is done in order to simulate the time a real user might wait or think while taking action on the web page. A user will never go just like login, search, place order, payment, and log out within few seconds. He requires some time to think and do next action. By this, we also achieve the user concurrency by extending the user session on the server, and we can emulate the behavior of different users from no voice user to expert user. On the other hand, pacing instructs the virtual user to wait for a given period of time before starting the next business flow cycle. Pacing is used to regulate the rate of requests that are hitting the server, and using pacing, you can accurately achieve the desired load as per the NFR instead of just bombarding the server with requests. Correct pacing gives the exact load handling capacity of a server in terms of TPS or the transactions per second. Now, what is this TPS or transaction per second? A transaction is a group of requests, and transactions or mechanics which is used to measure the server response time for any operation. In simple words, the use of transaction helps to measure the time taken by the system for a particular request. It can be as small as click of a button or an AJAX call upon focusing on the text box. Example for transactions can be a login transaction, search transaction, etc. Whereas transaction per second or the TPS, it shows the number of transactions sent by the users in 1 second. TPS is one of the key metrics in the non-functional requirements, and it helps us to set the expected load on the server. We will cover this in more detail in the further videos. Now, moving on to baseline and benchmarking. When any software application undergoes performance testing, they will record the performance testing metrics in terms of various application aspects. After a certain period of time, when the same application upgrades, a new feature comes in, like a system feature or a system upgrade or hardware upgrade or patch release, etc., then the performance testing team executes the test to determine how the new performance testing metrics are collected, and then it is compared to the metrics against the baseline metrics which was collected and documented before. This is the feature which we covered in the regression objective of the performance testing in my previous videos. This kind of testing is called as the baseline testing. Now, benchmark testing on the other hand is the company-wide agreed standard for the performance testing metrics which every software application that belongs to the organization should pass. Preferably, the baseline performance metrics values should not exceed benchmarked performance standard. And a key rule for a benchmark is that it is supposed to be repeatable. For example, while doing different load testing, if the response time varies every time, then the system performance testing should be benchmarked. The response time on all conditions and loads should be constant. Now, let us see what are hosts. When you execute a performance test scenario, each viewer in the test is distributed to a host. The host is a machine that executes the viewer scripts, enabling the viewer to emulate the actions of a human user. Now, what is a scenario? We divide our application performance testing requirements into scenarios. A scenario defines the events that occur during a testing phase or each testing session. For example, a scenario defines and controls the number of users to emulate the actions they perform on which machines are they going to run and from which machine they are going to emulate their load. At last, let us understand what is a reduce point. Reduce point means meeting points. In just one line statement, it can tell our testing tool to introduce concurrency. You insert reduce points into the scripts, and these reduce points shall instruct the users to wait during the test execution for multiple users to arrive at a certain point so that they may perform a task concurrently. For example, to emulate a peak load on a banking server, you can insert a reduce point instructing 100 to 1000 virtual users to deposit cash into their accounts at the same time. This can be achieved using reduce. Now, let us see one of the most fundamental law of performance testing, that is the Little's law. John D.C. Little is an institute professor at Massachusetts Institute of Technology and is best known for his result in operations research, that is the Little's law. Though Little's law first originated as a part of operations research, Little's law in many ways can be looked as the foundation of everything we do in the performance testing world. Little's law helps us to understand the reason why systems bottleneck and provides a simple approach to understand concurrency or users in a system. What does this law basically state is the long-term average number of customers in a stable system, L, is equal to the long-term average effective arrival rate, lambda, multiplied by the average time a customer spends in the system. Here it is W. Now, we have just seen what does Little law define. Now let us see where do we apply Little's law in performance testing. We apply Little's law for performance testing in these following scenarios. First, model performance testing workload. Next, to validate the performance testing results. After that, to validate the sizing models that your infrastructure guys have come up with, or to validate the non-functional requirements that your architects have recommended. Let us see a simple example theoretically how this Little's law works. Later, we will see in the further videos when we are doing our testing practically and apply how Little's law is working there. Here goes a sample scenario. We will determine the concurrent users using Little's law. And my scenario is a system at peak processes 8,000 transactions per hour with an average response time of 5 seconds per transaction. And here we are taking our think time per user for an average of 30 seconds. And what are we to find here? We need to find the concurrent users which are running on the system. For this, first we need to calculate the transactions per second or the throughput. Here they have given 8,000 transactions per hour, which means 2.22 transactions per second. And now we know Little law's formula is L equal to RT plus ZT into X. Here I am taking L as the number of users in the system, RT is my response time, ZT will be my think time, whereas X is nothing but my throughput or my transactions per second. Now applying this equation, I get 77 users, which means the above system has approximately 77 users at peak driving 8,000 transactions per hour. So this is one simple application of Little's law. We will see the rest of the scenarios while we design and execute performance tests in my further videos. Now we have seen the Little's Law and we have learned the terminologies. And to do a performance test, we need a tool. There are many tools available in the market for performance testing, and the majorly used ones are the below. In here, if you see, there is only one major open source tool available for performance testing in the market, that is Apache JMeter, and the commercial tools are Micro Focus LoadRunner, which was formerly HP, next the IBM Rational Performance Tester, then Micro Focus Silk Performer, this was formerly owned by Borland, next Microsoft VSTS, later Neotis Neoload and Smart Beer WebLoad UI. These are the mostly used commercial tools. Now, we have these many tools available in the market, and how do I decide which tool to select for my tests? How do I decide it? These can be decided using three simple criteria. 1. The protocol support the tool provides. Load testing tools either emulate load or they simulate load. Simulation involves duplication of actual user activity on the GUI or the front end with the intention of replaying it again. Emulation involves protocol replay. For this, a rich API protocol related functions are required. A good tool is not supposed to be restricted to single protocol, and it should support multiple protocols like HTTP, HTTPS, FTP, Oracle, Citrix, or PeopleSoft, Siebel, anything. And the next criteria to select would be strong scripting language. The scripting language supported by the automated tool should be understandable and precise. It should not generate lengthy codes which are difficult to maintain, and it should resemble to common languages like C, Java, etc., and it should be easy to debug. And the last criteria to consider would be record and playback support. This category details how easy it is to record and playback a test. Is there object recognition when recording and playbacking, or does it appear to record okay, but then on playback without environment change or unique ID etc. changes, does it fail? How easy is it to read the recorded script? So using these criteria, you can select which tool would perfectly suit your performance testing. Now let's move on to our much awaited LoadRunner. LoadRunner is a performance testing tool which was pioneered by Mercury in 1999. LoadRunner was later acquired by HPE in 2006, and in 2016, LoadRunner was acquired by Micro Focus. LoadRunner is not only a pioneer tool in performance testing, but it is still the market leader in the performance testing paradigm. In recent assessment, LoadRunner has about 85% of market share in performance testing industry. LoadRunner supports various development tools and technologies and communication protocols. In fact, this is the only tool in market which supports such a large number of protocols to conduct performance testing. And performance test results produced by LoadRunner are used to benchmark against other tools also. Broadly, LoadRunner supports RIA, that is Rich Internet Applications, Web Protocol, Mobile, SAP, Oracle, MS SQL Server, Citrix, RTE, Mail, and above all, it also supports Windows sockets. There is no competitor tool in the market which would offer such wide variety of protocols vested in a single tool. And what is more convincing to pick LoadRunner for performance testing is the credibility of this tool, and LoadRunner has long established a reputation, as often you will find clients cross-verifying your performance benchmarks using LoadRunner. LoadRunner is tightly integrated with other HP tools like QTP or ALM, which empowers you to perform end-to-end testing process. LoadRunner is mainly made up of three components. First is the VUGen, or the Virtual User Generator. VUGen, or the Virtual User Generator, it is an IDE or a rich coding editor. VUGen is used to replicate system under load behavior. It provides a recording feature which records communication to and from the client and server in the form of a coded script, also called a VUser script. This VUser scripts emulate the steps of real users using in an application. Next comes the controller. Controller is an administrative center for creating, maintaining, and executing test scenarios. It starts and stops load tests and performs administrative tasks. The controller, it controls the load simulation by managing what? How many vusers to simulate against each business process or a user group, behavior of the users, that is the ramp up, ramp down, the simultaneous or concurrent nature of the users, etc. And the nature of the load test scenario, that is the real life scenario or a goal variant scenario, or you are verifying a SLA, and which injectors to use, like how many vusers against each injector or the load generator. Next, collating the results periodically. It also supports IP spoofing, error reporting, transaction reporting, etc. And now comes the analyzer. This uses the load test results from the controller to create graph and reports that are used to correlate system information and identify both performance issues, and also helps to identify bottlenecks. There is another component in LoadRunner, that is the agent process, which is installed on the load generator machine, and it acts as host location for simulating vusers. These agents can be installed on any machine across the globe to simulate the user load on the system. Now, the LoadRunner controller is responsible to simulate thousands of vusers, and these vusers consume hardware resources like processor and memory, hence putting a limit on the machine which is simulating them. Besides, the controller simulates the user from the same machine, and hence the results may not be precise. To address this concern, all users are spread across various machines called as these load generators. As a general practice, controller resides on a different machine and load is simulated from a different machine. Depending upon the protocol of the user scripts and machine specifications, a number of load injectors or generators may be required for full simulation. For example, users for an HTTP script will require a memory footprint of around 2 to 4 MB per user. Hence, 4 machines with 4 GB RAM, etc. will be enough to simulate a load of 10,000 users. Now, architecture. Here, the LoadRunner architecture does seem complex, right? Yet, it is easy to understand. Now, let's understand this with an example. Suppose you are assigned to check the performance of an e-commerce site, say with 1,000 users. In a real-life scenario, all these 1,000 users will not be on a home page, but in different sections of the website, right? Now, how can we simulate it differently? Now, what happens is, VUgen can record to simulate the business processes, say like some users might be surfing the product page, next some might be in the checkout page, and some may be doing a payment processing, and some may be in the account or previous orders page, etc. So we use VUgen to record these business flows. And now we can separate, like now having 400 users in my surfing page, and 200 users on my checkout, and 100 users are performing payment processing, and 250 users are checking my account page, and 50 users on my order history. These design happens in my controller. We can design even more complex scenarios using this controller that we will be seeing in our further videos. Now comes my LoadRunner agents. All these 1,000 users, where are they simulated from? They are generated from these load generators. The controller orders or instructs the load generators to simulate these particular number of users into my application, and this is how my execution takes place. Finally, after my load test is done, my analysis comes into picture. So, what is the role of this analysis during this execution? My controller creates a dump of results in a raw form and contains information like the version of LoadRunner created, and what are the transaction response time, what are how many number of hits per second did the server receive, what are the errors. All these details are captured, and the resulting result file is dumped in a location with all the configuration. Now, all the errors, exceptions are logged in a Microsoft Access database named output.mdb. This analysis component now reads this database file to perform various types of analysis, and it generates the graphs. These graphs shows various trends to understand the reason behind the errors, failure under load, and thus help us to figure out the optimization required for the system under load, or the server, or my infrastructure. So this is how LoadRunner works. Now let's move on to and see how to download and how to install LoadRunner. As LoadRunner is a microfocus tool, search microfocus LoadRunner tool download, and here you can see this is the microfocus website to download LoadRunner. When you open this, here you can see the trial version of LoadRunner to be downloaded. If you click on this link, LoadRunner will be downloaded. Else, you can go here to products and you can click on products A to Z. So when the products page from microfocus opens, here when you click on L, it takes us to LoadRunner. Here if you can see, there are three options available. One, LoadRunner Cloud. StormRunner is now LoadRunner Cloud. LoadRunner Enterprise is nothing but Performance Center. LoadRunner Professional is LoadRunner. Here, why does it say free trial or buy? As you can remember, LoadRunner is a commercial tool which is partially free, which means it supports only up to 50 users and only few protocols are available to try for free. If you want to work on different protocols and number of users like more than 50, then you need to buy the license. Now if I click on LoadRunner Professional free trial, it takes me to this page. Here you need to have a microfocus account to download any of their products. You need to fill in these details and sign up for a free trial. Else, if you already have an account, click on sign in. It will redirect you to their sign in page. This is the sign in page of microfocus. Provide your email here. Click on continue. Provide your password and sign in. So once you sign in, you can go to this trial version here and you can click on this exe link which is highlighted here. And once you click on this link, the LoadRunner download starts. Here you can see LoadRunner is asking to save a download version in your downloads tab. I have already downloaded the exe version, so I am cancelling it. But if you want to download it, you have to save it. Now let us see the downloads. Here is my LoadRunner 2020 Community Edition which was downloaded. Now if I double click on this exe file, you have to follow the steps displayed on the screen. Click on yes. By default, it selects the C drive for microfocus LoadRunner to be installed. If you want to change the drive, click on browse and select your required drive. Else click on cancel and continue to click on install. The installation will begin. If any prerequisite software is missing for the support of LoadRunner to be working in your system, the LoadRunner itself will show you the pop-up like this, like these prerequisite softwares are missing and that needs to be installed. You no need to install this separately. All these comes in the package of LoadRunner. You just need to click on OK to install these prerequisite software. So the prerequisite softwares have been installed. Now it is installing LoadRunner in my system. All this setups takes about 5 minutes max, so please be patient. It asks us an option to install LoadRunner or the enterprise host. Because we are not looking into Performance Center right now, we are installing only standalone LoadRunner. I am selecting LoadRunner and clicking on next. Here please read the terms and conditions, end user license agreement, and then click on I accept terms and conditions and license agreement, and then I'm clicking on next. If you don't want desktop shortcuts, please uncheck this checkbox.
or if you don't want to participate in any improvement programs, you can also uncheck the same. Click on next. So this is my default location where it is getting installed. If you want to change it, you have to click on this change button, else continue with next. And now when I click on install, LoadRunner gets installed.
Pop-up appears. I'm unchecking this checkbox because I'm going to use only a trial version of LoadRunner and I do not have any licensed version. And then I'm clicking on next. It finishes my installation and now my README file has opened, which has the details about the installation and the LoadRunner which has installed. And I have also opted for shortcuts, so which will be appearing in my screen. Here is my VUGen, my analysis, my controller. So you have successfully downloaded and installed LoadRunner. Congratulations! Thank you for watching this video. Hope to see you again soon. Do like, share, subscribe to our channel. And if you have any questions, comments or any suggestions, feel free to drop in our comment box. Thank you.